Have you ever stopped and wondered how exactly we talk to computers? How do we take an idea in our head and make it happen on a screen? Well, it all comes down to language. And today, we're going to look at how Python, one of the most popular languages on the planet, solves this problem in a really, really clever way. Let's dive in.
So at the very heart of this whole thing is a fundamental problem, a massive communication gap. It's like we're dealing with two completely different species.
For us humans, it's all about natural language, right? If I tell you to grab the book from the table, you just get it. You understand the context, the nuance, it's intuitive.
A computer, on the other hand, doesn't get any of that. It only understands one thing, machine language, a super strict, totally literal code of ones and zeros. It's just on or off. There is absolutely no room for interpretation.
So that brings us to the big question, right? How in the world do we bridge that gap? How can our complex, nuanced thoughts be translated into simple instructions a machine can actually follow?
Well, the answer is translation. But in the world of computing, it's not quite that simple. There are a couple of different ways to go about it.
Just like you'd need a person to translate between, say, Japanese and Spanish, we need a special kind of program to act as a translator between our code and the machine's code. Okay, so first up, we've got something called a compiler. You can think of a compiler as a super thorough translator. It reads your entire program, the whole thing, from top to bottom, and translates it all at once into machine code. All the work is done up front before anything actually runs.
And then you've got the interpreter. This is more like a live simultaneous translator. It takes your code one line at a time, translates that single line, runs it, and only then does it move on to the next one. It's a step-by-step, on-the-fly process.
Yeah, this is the perfect way to think about it. A compiler translates the entire book before you ever get to read it. An interpreter is like someone sitting next to you, translating each sentence as you go along. Totally different methods. So, which one is Python?
And this, right here, is where Python gets really, really smart. See, instead of picking one way or the other, Python decided to use the best of both worlds.
And there it is, the big reveal. Python is a hybrid. It doesn't choose sides. It actually uses both a compiler and an interpreter in this really elegant two-step system.
So here's how it works. When you run your Python code, it first gets compiled, but not into machine code. It gets turned into this intermediate language called bytecode. Think of it as a generic, low-level language. Then a program called the Python Virtual Machine, or PVM, steps in. And that PVM acts as an interpreter, translating the bytecode into the specific machine code for whatever computer you're on.
This is a fantastic analogy. Imagine your Python code is a recipe written in Chinese. The compiler first translates it into English. That's our bytecode. Now, English is a pretty universal language, so anyone who speaks English can now read that recipe. The Python Virtual Machine is like all the different cooks in the world, who can each read the English recipe and then cook the dish using their own native language, whether it's Hindi, Spanish, whatever.
Okay, so you might be thinking, why bother with this whole two-step process? Well, the reason is huge. It solves one of the oldest and most annoying problems in all of programming.
See, back in the day, if you wrote a program in a purely compiled language like C, that program was basically stuck on the kind of computer you built it on. So if you compiled your code on a Windows PC, it worked great on Windows. But if you tried to take that exact same program and run it on a Mac, no way. It would just fail. You'd have to go back and completely recompile the program just for the Mac.
But Python's hybrid approach completely changes the game.
Because Python compiles to that universal bytecode, you can take that one file and run it on any machine in the world, as long as it has the Python Virtual Machine installed. There's a PVM for Windows, a PVM for Mac, a PVM for Linux, and they all know how to read that same bytecode. This is the famous write once, run anywhere philosophy, and it's a total game changer.
And that flexibility, that portability, is the secret sauce. It's the reason why this one language can be used to build such a massive, diverse universe of applications.
You want to build for the web? Python's got you covered. You can create huge, powerful web applications using frameworks like Django, or smaller, more nimble ones with Flask.
Or maybe you're feeling a bit more creative. You can jump into game development. There are libraries like Pygame that give you everything you need to start building your own games from scratch.
And of course, there's data science and artificial intelligence, where Python absolutely reigns supreme. Tools like NumPy and Pandas are the bedrock of so much modern AI and machine learning. And it all stems from that one clever hybrid design.
So there you have it. We went from the basic problem of a human trying to talk to a machine to Python's brilliant two-step solution to the incredible freedom of being able to write code that runs everywhere. All of that power, all of those possibilities. So the only real question left is, what are you going to build with it?